Cool. We're done with that chapter. Let's go over some things that I thought were interesting. I'm trying to highlight things now, so hopefully that works. First, though, we have to zoom in. So there's a couple things here. Hopefully the camera picks up on it. I also realized that there's like weird little spindly doos, like little glitter effects. And while I do love glitter, I don't want that forever. So if anybody knows how to fix that, let me know in the comments, because I don't know cameras. So one of the things that was useful for me to recognize initially was that they're giving a ton of different definitions in this chapter. And so one of the things that I'm going to try to remember for next time, but not necessarily important for like knowing this chapter, is that it talks about things like a prelude here, which isn't part of the definition of anything we really touch on. It's more like, oh, this is the opposite of that. So when you start the program, the beginning types that are included inside that program are in this prelude thing. But when we add something, it's post the prelude, if I understand correctly. So either that or this adding standard IO at the beginning, this use call up here, adds this to the prelude, and then like everything before the first main call would be considered part of that prelude. The other thing that I don't necessarily know is if I could just use this call use anywhere in the program, and if I can do that, well then does like at the compile time, does it go through and find all instances where some external library was included, and at that point does it make that part of the prelude, because that makes sense, as opposed to doing it in more of like a, at this point in the execution I need to go reference. I don't know how that works. The other thing that was useful to know here is you have to define things as mutable, which makes sense, but from a programming perspective is a little bit different than I'm used to. Normally, if you're doing a good job, you consider what things need to be immutable and you define them as such. And in this one, everything is immutable until you define it to be mutable. So if I just simply said let guess equals string new, then it would be completely useless because, well, maybe not. Maybe I need an empty string to compare against or something like that. But you wouldn't want to do that if you ever intend to actually use guess to contain some sort of stringy stuff. Beyond that, it talks a little bit about a reference. So we're dereferencing things in some of these calls. So it says that we have an argument that's a reference here. When it's pointing to a reference to guess, we put the reference on the mutable call rather than on the guess. And it says it's going to talk about that in a future chapter, but that's a little bit strange. I would kind of have expected it to dereference the actual variable rather than like the mutableness of it. I don't know. The other thing is it talks about result types. So when you invoke something and you don't know whether or not it's going to work or not work, I've seen this in code with a dot unwrap, but here they're using one called expect, which is interesting. I don't know exactly the difference between the unwrap and expect, but it seems like it's just a way to say, give me the output if it works and otherwise break. And then beyond this, they're telling us that the actual result types from calls like this is that, calls like this is that they're going to be containing more than one thing, and you need to essentially like step through that and assert what errors actually break. Yeah, okay, here we go. So in this case, provided a match and then say if the error is okay in the enumerator, if the result is okay in the enumeration, then assign that value. And if it's not okay, then just continue. The other thing is, since we needed to generate random things, it's not part of the standard library. So it's included in a package which needs to be pulled from like crates.io. And that is included in your TOML file. And they're all semantic versioned, as you can tell from my wonderful highlighting. It's similar to other locking things that I've seen in the past. Having done Python, it's like a pip env and pip env lock. But what I don't quite understand is there's this update call. And when they say that this update call actually functions, it will update things if their minor versions were updated. but not if their major versions were updated. So in the case where we wanted to update it to 4.0 rather than, 0.4 instead of 0.3, we'd have to change that and then run update again. I don't know. Well, I recognize that would probably necessarily change what would happen in the cargo.lock, but I don't know if that's going to change stuff in the actual cargo.toml. So that's something worth checking out as well. The other thing that was cool here is it's talking about pulling this down from the crates.io. If I don't publish something, like if I have a private repository, I want to figure out how to potentially do something like that. But the other thing that's interesting here is it's like, if you don't know these things, you can actually just run cargo doc and then open, and then your browser will be provided with all the various libraries you pulled in, and you can like click through them and stuff. So that's something that I didn't know, and I'm going to be using the hell out of this in the future. I was surprised to find comparison call here for like ordering. It's not just provided, I guess. I recognize this is probably a super useful pattern, but like in my head, if I eventually get out a number, if this is less than my guess, then print blah. If it's greater than my guess, then blah, else, you win or whatever. So I don't exactly see what the value is of that other than maybe just telling us. Oddly enough, when I was going through this, I was confused because I was like, are we comparing a string to a number? And it turns out that exactly will break. And it says here we have to explicitly cast it and then we have to change it. So that's why we go up here and we trim and then parse. A lot of stuff in here. I'm going to try to program it. So let's zoom out and get going.
A few moments later.
Okay, so I finished programming it, and I actually had a lot of bits of confusion. So let's kind of dive into that. Firstly, in the cargo, I initially was like, I'm going to try to use the most update version of Rand, which may or may not have been a good idea. When I generate the docs with that cargo doc open, this RNG is version 0.8.4. So I eventually got it working with this most recent version, and the reason I know it's the most recent version is because I went to that crates.io website and then I looked up Rand and it told me this here, and that's great. It looks like it's got a lot of users. Fantastic. So the confusing bit was the book didn't use that. It used 0.3.4. And if I added this line and removed the first line, the code in the book worked as expected, which I'll write out here. Okay, so the way that the old version would work is that this secret number. Okay, so the way that this worked in the old API was I simply got a secret number, which was a 32-bit unsigned integer, by calling rand, then calling this thread RNG, and then calling genrange on it. And that produced the output as expected. This new one requires you to instantiate this RNG object from thread RNG and then call genrange on that object. What I don't understand here with this newer version, and perhaps why it's not included in this book, is if I was like trying to follow through with this without having examples, I wouldn't know what to do. This thread RNG call seems to be the only thing that's important for me to add in scope here. However, I need to include this greater RNG here for a couple reasons. If I open up the docs with the newer documentation, and I was trying to figure this out, let's say I didn't know gen range was a call, I'd say, well, I know thread RNG was something that existed in this older version, so I guess I'm going to try to find thread RNG, and I look here and I say, hey, look, here's thread RNG, so I click it, and then it says this function returns this thread RNG, I don't want to say object, but this struct, so I click it, and it tells me here's the struct, and here's its trait implementations, and all these auto traits and blankets and all this. And if I look here, I don't see anything associated with gen RNG, gen range. It doesn't exist, which is confusing. I don't know where that comes from, right? So this RNG struct that I get back implements gen range somewhere, And the only reason I was able to figure it out was if I actually went back to this rand and I looked around here. I still don't see gen RNG, but if I search, sorry, I keep saying gen RNG. If I search gen range, it shows that there's actually this RNG struct that gen range has provided, which is strange to me because I would assume that this RNG would be the struct that I'm calling here, but apparently it's calling from this struct. And if I look at this one, this is where it shows its actual usage here, and we see use rand here, and we include both the thread RNG and this RNG in that invocation. And by actually using this RNG, we can call gen range with what appears to be a range, not just two different values to that function. And so it's just a very confusing way for this to have executed. What I don't understand here is that if I don't include that RNG from rand and I expect to just call this RNG and then, call gen range off of it, when I actually do this cargo run here, it says, there's actually not a method gen range for thread RNG, which I guess makes sense. But then the question of, okay, I include this RNG, which contains this gen range. How does that get invoked, right? How does that actually function as expected when obviously there's no capital RNG in any of these example pieces of code? Or how would I have figured that out? Okay, hopefully that was useful to see somebody else struggle through. Let me know if you have any answers to the questions that I have, and if I get a reasonable response or something that brings clarity to me before the next video, I will include those and we will all learn together. Thanks for watching.